Hello, we are Team 2 from VTEPS. My name is Eric Alenko.
My name is Jason Lee.
My name is Wenkun Liu.
And this is our Design Phase 2 presentation. In this presentation, we're going to briefly update you on our project management. We are going to discuss our intellectual property search. We are going to go in depth about our concept generation and selection, as well as wrapping up with a failure modes and effects analysis on those stations and an economics analysis. This is our updated Gantt chart. A couple things to note here is that we had to extend the concept generation for stations 1, 2, and 3. That ended up taking longer than we thought, which made us push back our prototyping and shorten it, as well as a few other things along the way. Another important thing to note is how much more steps in the critical path there are, which means we really have to be punctual about those steps. This is our DSM chart. The important things to note here is that the concept generation for stations 1, 2, and 3 were coupled tasks, so we kind of went back and forth on those a little bit and continued to revise our designs. Also, the industrial design, design for an environment, those factors are also coupled, which just shows the sheer number of X's down here. That's important because we really need to make sure that we are being on time with that part of the design phase. This is a brief summary of our intellectual property search. We really ran into very few patents that limited our design, but we got a lot of ideas from searching it for other people's ideas. A couple things we got were to maybe attach the tracks and the stations together through electromagnets. We considered adding more problems into the equipment, simply to give the students something to engineer a little bit more problems to solve. We also consider including more measurements, being more precise, so that we can add that scientific element to our design. Also adding an artistic theme, something like space exploration or some other sort of theme to increase the aesthetics of the design. And finally, to include more technology, more cameras, or just more ways that we can incorporate technology into the design. That way, that part that's becoming more and more important in engineering is incorporated here. Next, we're going to talk about the concepts we generated, the 3 stations, and how each station has a specific function.
Okay, so the function of station 1 is to get the ball to move around the project, and here are the different ideas that we came up with. We came up with the ball, the V-shape, the half tube, the plane, the tube, and the wall. So immediately from the screening, we eliminated the rails and the tube, so we didn't even consider them. And then from the scoring matrix, the top score was the V-shaped track, and then the next highest was the plane track. But however, we did find an alternative way to actually make the plane track so that it would end up being higher, it would end up being a better score than the V-shaped track. And that's why we ended up choosing the plane track over the V-shaped track, because after we found an alternative way to manufacture it, the manufacturing ease for the plane actually ended up being higher than the V-shape, and that's how we went about choosing the plane track for station 1. And station 2 was about thinking of ways to raise the ball or give it more potential energy. And the alternatives that we came up with were the human-powered screw, the water elevator, the mechanical elevator, the conveyor, the chemical elevator, and the ball drop. And immediately from the screening, we eliminated the chemical elevator and the elevator. They were not very practical. And from the scoring matrix, the ball release and the water elevator were the top 2 scorers. However, it is important to note that we do plan on making multiple ways to make the ball go higher, not just one. So because the ball release was our top scorer, that's the option that we did trust the most. So we ended up actually making a prototype, or we ended up making a mock-up of the water elevator, because that's the one we didn't trust, there were problems with. So if we were able to make a mock-up of it, then we would figure out how we can fix it so that it can work together with the ball release. And then finally, station 3 was a way to give the ball more kinetic energy as it goes around the track. So we came up with the roller, the fan, the hammer, the loaded spring, the paddle, and the water wheel. And from screening, we immediately eliminated the water wheel and the paddle, so we didn't pay attention to them. And then from the scoring, the top choice that we ended up coming up with was the roller. And the roller was overall the best idea for us. It did well in basically all the categories. The other categories had their minor problems, such as manufacturing ease or ease of use. And the roller was the only one that was consistent throughout, and that's why we went with the roller. And now we will talk about the, failure modes and effect analysis.
So here is the failure mode and effect analysis for station 1. The biggest issue we have for station 1 is that the connection between the tracks, the edges of the tracks, they might not be consistent. So what that means is that the tracks won't work, so the whole station will fail. So we might need a more careful manufacturing process to ensure that issue is solved. And then for station 2, for the water elevator, the biggest problem with water elevator is a lot of cap on the reservoir. So if we can replace the normal screw cap with a pop-off cap, that will solve the problem of our station 2. And then for station 3, the problem is that the contact surface between the roller and the ball. So the solution is that we can increase the friction of the surface, or we can better position the contact surface of the roller and the ball, so the ball can have a better acceleration. So, and that's also the purpose of station 3. For economic analysis, this slide you can see the investment, the payback that VTAPS is paying, and the paybacks that VTAPS is getting. So as you can see in the cash flow diagram, this is a net value of those two values. As you can see, VTAPS is getting positive income after the first year product development, and we are going to sell our product and to gain some sales revenue. So that's why that's a less risky for VTAPS for this product. And this is our financial breakdown. So as you can see, the first thing is that the development costs are high because the development time is kind of short, is within a year. So that's the reason for that. And then we didn't make that much make that much products in the first 2 quarters. It's because we think the market may not be big enough for us to sell the much products. So we kind of cut a little bit of sales numbers on the first quarters. Even though, as you can see, the payback quarter is a little bit late. It's a little bit late. It's like the last quarter of the 3-year period, but I think the 25.8% IRR is really competitive and really worth VTAPS to choosing our project.
In this presentation, we've covered lots of topics. We've given you a brief summary of our project management. We've talked about the intellectual property search we've done. We've gone in detail about the concept generation and selection process, as well as the analysis we've done on those, and the economics proving that this is a profitable project for VTEPS to pursue. We are Team 2 from VTEPS. This is our Design Phase 2 presentation. Thank you for listening.
Thank you.
Thank you.